This Barron's guy. What a great book.
Oh my god, hey Dad! Guess what I learned at school today?
Oh hey son, guess what? I baked you a pizza. It's nice and warm right now.
Dad, we don't have time for that. I gotta show you something.
Alright son, show me what you learned today.
Gee, my mind is just so full of knowledge.
What?
Today we learned related rates.
Can you teach me a classic related rates problem?
I sure can, Dad. Alright, Dad, this is what we call in the business a classic ladder problem. Okay, let's say we have a 13-foot ladder resting against a wall. Here's our ladder, here's our wall. And the ladder slides down an exterior wall at a rate of 1 feet per second. How fast do you think the distance between the base of the ladder and the base of the wall changing in feet per second when the base of the ladder is 5 feet from the wall? So this would be 5. Right? So what we're trying to solve for here is how fast it's going to be moving down the wall, and we're going to have the wall be y. Any questions so far, Dad?
So far it makes real good sense.
Okay, we have to start with a concept called the Pythagorean theorem. Do you know what that is, Dad?
What? What on earth?
I'll teach you. X squared plus y squared equals z squared.
Are you sure?
I'm positive. Now, to solve this, we're going to start by deriving this equation.
Alright. That looks like some classic deriving.
Oh, you're sure right, Dad. Now, since that our z, which is going to be our hypotenuse here representing the ladder, since we know that that ladder is not going to be changing in any way, right? It's going to stay the same size. We know that its derivative is just going to be 0. Doesn't that make it easy?
Very easy.
And since we have a 2 as our coefficient, big words we're using now, Dad, keep up.
What?
We can actually cross these out to make it simpler for us and rewrite it as x dx dt plus y dy dt is equal to 0. Now, the x is our 5 from over here, which represents the base of the wall. And then here's our dx dt, which is the rate at which it's changing. The same is for the y and the dy dt.
But we don't know why, son.
We don't know why.
How do we do that?
Why? Let's figure it out.
Why?
Ha! Okay. So, we're going to solve y by coming back to our Pythagorean theorem. So, we know we have our x squared plus y squared equals z squared. Well, we know our x. That's 5 squared. We don't know our y, so we're going to stay that the same. That's the variable we need to solve for. And set it equal to our z, which we know is our 13 squared. Now, we're going to take our 5 squared, put it over the other side. 13 squared minus 5 squared. Now, do you know what 13 squared minus 5 squared is, Dad?
Oh, I don't know how to do that, but good thing I have my calculator for me.
Whoa! Don't be so calculator dependent, Dad. Think for yourself sometimes. Jeez. Without using our calculator, we know that y squared is equal to 169 minus 25. Now, what does that equal?
I don't have that many fingers, son.
Aw, gee, Dad, let me show you. Y squared is going to be equal to 144. So, we have to find out what y equals. So, we're going to come over here. Y is going to be equal to the square root of 144. So then y is going to be equal to 12. How about that? Wow. So we're going to come right over here, and we're going to plug these variables in. So, we know our x, which is 5. Then we have our dx dt, which is what we're solving for. So that, obviously, that rate's going to stay the same. Plus, our recently solved for y, 12, times the original rate given for dy dt, which is 1. It's going to be equal to 0. Now, we're going to have to isolate dx dt in order to solve for it. So we're going to get the 5 and 12 over to the other side. So it's going to become 5 dx dt is equal to negative 12. And then we're going to take the 5 over to the other side. It's going to be dx dt is equal to negative 12 over 5. And then we've solved the problem, Dad. Or Negative 12 over 5 is equal to what?
Is that 3.5?
No, no, no. You're close though.
Let me get my calculator out again.
Stop! Or negative 2.4. But what am I missing?
Your units, of course.
You're sure right. Feet per second. That is the rate at which the base of the ladder is moving outward from the wall.
You're so smart, son.
I know.
Well, son, I think I've got the hang of this. I'm gonna try one of those classic Washington Monument problems.
Well, if you think you're ready.
Alright, son, how tall do you think that Washington Monument is?
15 feet, maybe?
Pretty good, pretty good. And our moving object, what do you want it to be?
Let's do a dog.
Should we name it?
What will we name it? Let's do Lucky.
What?
Yeah.
That's such a cute name.
I know. Let's say it's a husky or something like that.
Alright, so we're going to make this monument 15 feet. Now, key thing with these problems, son, is make sure you draw the picture. If not, your teacher will definitely take off points unfairly. So we said it's 15 feet. How tall do you think we should make that cute dog Lucky?
It's a husky, so it's pretty big. Let's go with 6 feet.
That sounds about right. So we're going to make this part of the graph or of the picture X and this part of the picture Y. So with these problems, you have to imagine you have the sun here and that this part over here is going to be your shadow. So with these, you always want to set up a proportion. So you'll want to do 6 over 15 and Y over X plus Y. The reason you want to do it like this is for this triangle right here, your height is 6 and your length is Y, as they correspond right here. For this bigger triangle, your height is 15 and your total length is the distance of X plus Y, as you see it right here. Your next step is to distribute. So you'll want to go 6X plus 6Y equals 15Y. And you'll just solve from there. And then you conclude that Y equals 6X over 9. From there, you'll want to take the derivative. So dy dt equals 2/3 dx dt. And we know from what the problem gave us originally that dx dt equals 5 units per second. Oh wait, no, it's feet. I'm sorry, son.
Gee, Dad. So dependent on that calculator.
Then from there, you just plug that value in, and you get that dy dt equals 10 over 3.
Wait, that can't be the whole problem.
You're right. Okay, son, so now that we know it, that dx dt is 5 feet per second, which was given to us, and that's the rate at which Lucky is moving away from the Washington Monument, and we've also solved what dy dt is, 10 over 3 feet per second, and that's the rate at which Lucky's shadow is shrinking. Now we have to find dx plus y dt, which is the rate at which the tip is changing.
Aw, show me, Dad.
So the way you do that is you have to redo what you did before, so 6x plus y equals 15y. Then you isolate the x plus y because now we're looking for that. You get 15 over 6y. Now you have to take the derivative of both sides. So you get dx plus y over dt, which equals 15 over 6 dy dt.
Oh man, we just solved for that.
That is correct, son. You're making me so proud. Then you plug that in to your equation over here. And do you know what that gives us, son?
Well, I don't need a calculator, so if I had to guess, I'd say that was about 25 over 3 feet per second.
I always knew you were better than me at math.
You're
And that's
sure
how you
right.
get your final that's how you get your final answer, son.
Wow, Dad, you're a really quick learner. I'm impressed.
All of these related rates have really worked up my appetite. Let's go get some pizza.
Still warm. We worked quick.
Son, you have made me one proud father today.
Thanks, Dad.
Oh, look who it is.
Brayden, do you want to learn about related rates? No.